Thank you. Good morning, everybody. Thank you, Sarah, for inviting me to do this. And I'm indeed going to talk about the SWIMMR program, which my name is on the talk, but the credit for belongs to a huge number of people distributed around the country, some in this room, multiple universities, which I'll name check, colleagues at RAL, and particularly our friends from the Met Office, without which this whole enterprise would have been entirely pointless. So what is SWIMMR? SWIMMR stands for Space Weather Innovation, Measurement, Modelling and Risk. And it is a program that's just coming to an end now. It was a £20 million 5-year program funded by something called the Strategic Priorities Fund of UKRI. And actually delivered by two research councils, that's ourselves in STFC and NERC. SPF is to do with delivering strategic priorities through academic collaboration, and as well as our colleagues at the Met Office Space Weather Operations Centre. This program was very much designed in collaboration with BAIS, as it then was, DFT and MOD. And since the breakup of BAIS into multiple ministries, our governance has been via DESNES, the Department of Energy Security and Net Zero, which is the risk-holding ministry for space weather in the UK. And our mission has been to work with academia to develop and deploy new models, instruments and test facilities to support the UK space weather community, and in particular our national capabilities vested in the Met Office. And so we have had over these last 5 years 11 projects running, more or less distributed equally between STFC and NERC, in fact 5 in NERC, 6 in STFC. All of our NERC projects were funded on NERC research grants, and our STFC projects we used every club in the bag, from grant funding to contracts and in-house work, procurement, etc. So I'll run through those 11 projects very briefly, starting with the 5 on the NERC side. This is what we call SWIMMR N1. It is a satellite radiation risk forecasting utility using a model built by the British Antarctic Survey, in fact 2 models, one for the electron radiation belt and one for the proton radiation belt of the Earth's magnetosphere. So we're looking at satellites relatively far away from the Earth, and using a real-time system to forecast their radiation exposure based on predicted geomagnetic activity. And embedded in this, there are tools to quantify the risk of damage and degradation. Those 2 models have now been delivered to the Met Office, along with some of the tools. There was one thing that we haven't quite achieved in this program, which was the extension to lower altitudes, which we hope to pick up with some follow-on funding. SWIMMR N2, this was led by the University of Surrey, and again it's a radiation modelling program, but this time radiation modelling for the aviation environment. So this is radiation exposure for aircraft, and it's provided via a global model called MARY Plus and a research version of that model called MARY R. These models are developed in Surrey, and they will be the precursor of a radiation monitoring service and forecasting service for the UK, which we hope to underpin by observations made with some monitoring instruments funded by another project, which I'll talk about in a moment. So this was actually our first model to be delivered to the Met Office. It's already been used in conjunction with some international colleagues. This N3, N5 was intended, or at least had the possibility to be 2 separate projects. It turned out to be 1, led by the University of Birmingham for modelling the ionosphere and thermosphere. And of course, the ionosphere is the charged component of the Earth's upper atmosphere, but it's embedded in the neutral component, which is the thermosphere, and that modelling is obviously best done self-consistently. So this is basically the same model. It uses a data assimilation tool called INEAS, and we are using that in the modeling to provide forecasts for things like ionospheric absorption, scintillation gradients, relative to global positioning and HF performance. And there's another future application of this, which I think is very interesting, which is to measure the effect of geomagnetic activity on the dynamics of the upper atmosphere, and then fold that back into our models of orbit prediction and satellite positioning for use in the kind of future tracking and space traffic management activities, for which we could devote a whole separate Appleton, I think. That one is a very complicated model because of the data traffic involved. It's being deployed on high-performance computing in the Met Office. The process for doing that is rather long, but it will hopefully come to an end next spring. And the final project on the NERC side is the modeling of what we call ground effects. So these are ground-induced currents. They are induced by currents flowing in the upper atmosphere during active events like aurora, but that in turn induces currents in ground infrastructure like power grids, pipelines, rail systems. And so to model the effects of that, what's had to be done is to develop a ground conductivity model, an improved one for the UK, and connect that to models of these various networks in the UK. That was underpinned by some measuring instruments which were deployed in the field. Those will survive the SWIMMR program at least by some while, and they're in the field now. Again, that model is delivered to the Met Office. Doesn't follow, as I'm sure Met Office colleagues will want me to say, that all these things are yet operating, but I'll talk about the future at the end of this talk. On the STFC side, our largest and most ambitious project is what we call SWIMMR S1. It's a project for radiation monitoring. So this is the kind of data that would underpin the modeling programs that you just saw. So in space and in the air. We had the objective of flying 2 radiation monitors to space, one at 645 kilometers orbit, and we really wanted the 1200 kilometer orbit because that was that's the OneWeb altitude. So we wanted to use this project to explore the radiation environment that OneWeb would experience. We have had one of those launches, the lower altitude one. We will have the second one, not to a circular orbit, but to an elliptical one in January. In the bottom right, in the bottom left, actually, you can see the results from our first space mission. The hot pixels where we've got the largest radiation doses are in the purple. And if you know about the Earth's magnetic field, you'll see that corresponds to the South Atlantic anomaly. On the bottom right, you'll see the detectors built by the University of Surrey called SIRA, which will be going into aircraft. And we have a couple of commercial partners who will be carrying these for us. I believe that some of them actually received sensors from us this week. So we're just concluding contracts with those before they start to fly. And top left, you see the sensor that was actually flown to space, which is produced by the Czech Technical University for our radiation monitor on a craft belonging to D-Orbit. And I don't know whether there are people involved in D-Orbit in this room. They quite possibly are. In S2, we again have been working with partners on the campus. This is a facility called CHIP-IR. It lives in the ISIS neutron facility, and it's used by commercial customers to test the radiation resilience, typically of their electronics hardware. We have paid or co-funded at least some upgrades to the CHIP-IR facility, including 2 small sources to these are lower energy sources to make the facility somewhat independent of the ISIS main beam, which supplies the high energy neutrons. And we've helped them advertise their facility better and more widely, and we've actually subsidized some users to come and use it to increase their user base. So that project is now finished. It ended in the spring. We have built a computing project, a portal to transition from research into operations. And this has been a collaboration with the Met Office and 2 of its digital partners to build an environment where academics and Met Office staff can collaborate internally to transition models into operational use. That was implemented by the beginning of this year, but it will carry on being used for the future. Met Office staff will continue to develop it under their own resources. This is our S4 project. It's Aberystwyth, Reading and Durham, and it is a bunch of solar wind and coronal models being used to complement and improve the current forecast facilities like Enlil that the Met Office already has. for forecasting the solar wind, which of course drives all the space weather at Earth. Again, most of that stuff is now in the Met Office. There is one element that is written in IDL at the moment, which needs recoding to Python before it becomes operational. Our S5 project is led by the University of Lancaster, and it is for the construction of ground-based neutron monitors in the UK, positioned at key locations. So our largest instrument is the one constructed by Lancaster. You see it bottom right on the right-hand side. This is the detector that's going to Camborne, and it has been containerized now. It will be delivered to Camborne next Tuesday to the Met Office site there. On the left of that picture is the smaller version of the detector that is going to Lancaster, and we are paying separately under a different contract for the University of Surrey to deliver a third detector to the Met Office site in Lerwick, which we hope will go in February. And then finally, but not least, we worked with Rhea UK, now Starion UK, and No Space and the University of Northumbria, who we commissioned to deliver an impact report on the impact of space weather on critical UK infrastructure. And the aim was to use the 2013 Royal Academy of Engineering report by Cannon et al. As a jumping off point, and basically to understand how things had changed since then, covering strategic economic factors, risks, new technology areas. Our task was to get this through peer review. We are still trying to clarify how that peer review will be finished before we issue the final version. So that's the program. Where are we going from here? So what I think we've done is we have been an enabler to significantly increase the UK's operational base for space weather. Moswak, of course, had a very good suite of operational facilities before we came along, but they were mainly built on the back of the US capabilities. What we've done is to put indigenous UK capabilities into the system, and we've exemplified what we call research to operations. So we've moved models and data and instruments from academia, where they started as research programs, into forecasting use. This program will end next year. I think it's been a paradigm for how we can deliver as UKRI to the strategic aims of UK science with the funding mechanisms that we have and the relationships that we have. But we're not done. So we've done, as I said, we've done research to operation. What we want to do from here is to move from research to operations. We've taken a pile of stuff, dumped it on Met Office's doorstep, to research to operations to research, where we actually re-involve the research community in tuning these models and data to get them operational and really match them to user requirements. So an R2O to R program is where we're hopefully going next. We have a placeholder in the National Space Strategy Implementation Roadmap, which might lead to an opportunity to do that. We have been talking to some of our governing ministries about establishing a program like that, but it's clear we need to wait for the new funding cycle, which won't come until CSR phase 2, beginning 26-27. We have a proposal that has been through a pre-selection process in STFC, doing R2O to R and also more internationalization of the UK outputs, and we will tune that according to whatever opportunity presents itself. So that's me. Thank you.
Thank you very much, Ian. You did a really great job in pulling together what is actually a massive program into just a few short slides. And it dovetails really nicely into Chris's talk right at the start about the importance of the work that we do on critical infrastructure and our everyday lives. So thank you. I'm sure there are lots of questions. Raise your hands if you have one. Right here. Perfect.
I've got a really simple one. Why do we study neutrons, the level of neutrons?
Because of their, well, basically because of their ability to mess with electronics, I think. So it's really, I mean, the growing industry, and I don't know whether somebody like Chris Frost is here who could answer this better than me, is for things actually like internet routers, microelectronics, autonomous systems. That's basically the big driver, I think.
you had 11 projects. How
Yep.
many more would you like to have?
Well, I think first of all, we'd like to capitalize on those 11 projects and really make them effective. So before we start running after a lot of new things, I think we really need to make sure that these things are in operational use and are working according to user needs. So that's what R2O2R is about. I would love to do more actually in increasing the sensor environment to get more data into the system, because space weather is very data sparse still. And I would love to make more connections to other communities. So some people in this room know I'm very interested in space sustainability and space traffic management and how we use space weather data in conjunction with satellite tracking data. We'd like to do much more of that.
Two more questions, one and then two.
It's a quick one that you might not be able to answer, but you say that the projects are due to all come to an end next year, but the next funding cycle is 26, 27. What risk do that pose to losing talent, to people's attention, being drawn away and kind of not being able to build on these fantastic foundations?
Well, you know as well as I do, Catherine. I mean, it's the obvious risk that your army will go away, and we've seen that in this project already. I mean, we've lost RAs, very good ones who've been working on this project as funding has come to an end. So a lot of these grants are now on no-cost extensions. Some have completely finished. The RAs who are working on them have understandably gone off to new careers. And it is to be hoped that if we do pick up a follow-on program, we'll get a new generation of RAs, and maybe we'll manage to hold on to some of them. But I think it's a perennial risk in this kind of endeavor.
Final question from Paul.
Ian, thank you. That was really clear, brought to life just the power of SWIMMR. Could you expand a bit more as you look to the future? You talked about what SWIMMR might do, but going further into space weather and with the Vigil program, what are the lessons we need to learn?
Yeah, no, I mean, the Vigil program is actually vital, and I should have mentioned it when the question of what we'd like to do next. Yes, I mean, Vigil will give us obviously a unique viewpoint of solar wind activity from the side. So all the modeling we've got at the moment is largely connected to observations along the Sun-Earth line. And that's why we need Vigil, because it will add a new geometrical viewpoint and hopefully constrain the modeling that much better. So there is definitely a big activity to be done in using that L5 data. And maybe if we ever go to L4 or if we have more missions like stereo, but those other angular viewpoints for constraining our solar wind models much better.
Thank you very much. And thank you once again, Ian.